Hi there, my name is Varun Rana, and today I just wanted to take the opportunity to demonstrate a replica of a bridge I've been working on. So this is Strauss movable bridge, and it's replicated after actually a real bridge on which I worked on in a professional capacity. While working on the bridge, I had an idea to first make a small replica of it, but also make a remote data acquisition system. So let me just show you the different elements of the bridge. The whole bridge is made up of, most of it at least, is made up of popsicle sticks, which I bought from Walmart and which I put together using a hot glue gun. It's also put together by screws, and I also used a cutting board for a base. So I'm going to demonstrate the movement of the bridge. So this is a movable bridge. In a typical application, this bridge would move up and down and ships would pass by and come back down for the road traffic to pass by. It has frontal leaf and a counterweight system. Now I'm going to show how the bridge can be operated by a motor. So I'm going to connect this strut, which will move the bridge up and down instead of me using my hand. The most difficult part to construct this bridge was the strut frame, and the difficulty was to make the motor, the pinion of the motor, align and mesh with the rack. I actually made the rack using a pulley belt and just glued it on a piece of wood. In order to mesh the rack and the pinion properly, I had to design the strut frame with oblong holes on X and Y axis so I can adjust them using screws and nuts so I can get the precise alignment. So the motor I used to move the bridge was a DC motor with a gearbox in front of it. The DC motor is controlled by an Arduino board. Now Arduino board is a prototyping board which is open source, and in this case, to control the motor, I connected the Arduino board to another shield called Ethernet shield. I did this so that I can host the controls of the bridge on a web server so that it is accessible by any internet enabled device. Now one thing to remember is because the motor, the microcontroller cannot have a lot of current passing through it, the motor has to go through a motor driver. In this case, I'm using a L298H bridge to control the DC motor. I also made a quick power supply, an adjustable DC power supply, so that I can provide the power for the board. I'm going to show you how it actually works and demonstrate it right in front of you guys. So if you look at my Android phone, I've put in the IP address and I have the web server running right here. So I'm going to choose the settings. I'm going to say opening mode, select low speed, and I'm going to turn the bridge on. Let's see what happens. It should automatically stop at a certain limit switch. Great. I'm going to put it back down at a higher speed. High speed, closing mode, start. Great. One other thing to remember is I also have a sensor on the bridge which can monitor the positions. So it senses when it's in the opening position and the closing position. I'll also be sending this data and visualizing this data on the internet and on my computer. That's the next part. Next, I'm going to demonstrate how I can, at a very low cost, actually log the data of the sensor and publish it on the internet or on a web server or on a computer. So if you look at this, I've used an open source API to visualize and plot the data right on my computer. This can be also put on a web server or a browser. Now I'll start the bridge again and you'll see how the readings change. Here I'm demonstrating the opening and closing of the bridge. As you can see, the sensor is going up and down as I'm controlling the bridge. So the demonstration I just showed you was a proof of concept. However, in the future, I would like to make the system much more robust and handling a lot more sensors. So for future, I would be using a Raspberry Pi. So what I would do is I would connect the Arduino board to the Raspberry Pi via the USB cable and host a LAMP server with Linux and Apache and MySQL and PHP. Host a server on there and publish all my data on the web server of the Raspberry Pi. This way you can collect multiple sensors and visualize multiple data from remote locations to any device in the world.